Okay, so now we're going to talk about section 3.2 and 3.3, which are the truth table sections. They show us how to construct a truth table and to evaluate those. So if you have your notes printed off, we'll be following along with that. So for example, say I had two statements. So I'll call let P be statement, my name is Cindy, and Q be statement, I teach at ACTC. So we could evaluate each one of those as true or false, and we talked about that in section 3.1, that a statement can be assigned a truth value, can be judged true or false. So we could decide, but let's say you don't know. You don't know if my name's Cindy, and you don't know if I teach math or teach at ACTC. So we're just saying, what are the possibilities here? Maybe my name is Cindy, and maybe I do teach at ACTC. Maybe both of those are true, or this part could be true and that part false, or vice versa, or they're both false. So a truth table just organizes the possibility without really going into looking it up to see if those things are true, which we could do and we will do later on in the section. But just for this part, just know a truth table just organizes the possibility. So we've got these two statements, whatever they are, it doesn't matter. It can be bizarre statements, whatever kind of statements, that doesn't matter. Just know we have a statement P and Q would make the same sort of truth table regardless of the statements. We would say case one is both could be true. That could be happening. Or statement two, case two, the first one's true, the second one's false. Or case three, the first statement was false, the second statement's true, or maybe both statements were false. That's just a way of organizing the possibilities. All this is going on here. So, and there's no magic to these being in order 1, 2, 3, 4. They could be in any order, but normally whenever you work one of these problems, they'll kind of have that already stamped onto your problem because that's just kind of standard. Here's the possibilities. All right, so that's a standard. Whenever there's two statements, a P and a Q, we usually use P and Q first off. But let's say there was a third statement. This thing can only get larger here if there's more statements involved. So let's say the next thing going on down is I add another statement, R. I love ice cream, which I do. I love ice cream. Now, it matters not that all of those just happen to be true. Again, doesn't even matter. We're not trying to judge them true or false in this particular concept. We're just saying, what are the possibilities? So now there's 8 possibilities. So it makes a much more elaborate truth table, because do you know this? If you have 3 things, there's 8 different ways that you could combo that up. So either all of these were true, that's the first case. They usually start with that. And again, there's no magic to these orderings, mind you, but this is just the way you usually will see it in the book, in this order. So the first case is, I am Cindy, I do teach at ACTC, and I do love ice cream. Maybe all 3 of those things are true. That's case 1. Case 2, I am Cindy, I do teach at ACTC, but I don't like ice cream. That was false, maybe. Case 3, I'm Cindy, I don't teach at ACTC, and I do love ice cream. That's another possibility. Case 4, I won't go through all of them, but just know that all of these would make different combinations of the way these things could hash out. And then lastly, the 8th case, maybe they're all false. Maybe I'm not Cindy, maybe I don't teach at ACTC, and maybe I don't like ice cream. Maybe all 3 of those statements are false. So again, the truth table just organizes the different combinations of ways these could be true and false. Now, that's as far as we go, but just know if there was a 4th thing, if I put an S, for example, and said, the sky, or I'm located in Ashland, I'm trying to think of something else I could say, I wear glasses, I could have a 4th statement, then it doubles this table. Every time I add in another factor, another statement, the table gets twice as big, so that would be really messy if you had to have 16 of these cases. But there would be 16 cases if I had 4 statements, and so on. But we don't go that far. This is all we'll do. The 8 cases, you'll need to know that truth table. We'll use that a lot. And then the 2 cases we had over here. All right, so that's just an overview of just the starting of having a truth table. Now, at the bottom of the page says we could create the compound statement. My name is Cindy, and if I use the word and, we talked about that in the last session, that is a connective, and the word and I teach at ACTC. So under what conditions would that be true if you use the word and? So let's go back to just the two there. And look at the next page. So that's a conjunction when I use the word and between these. If I say and, that means P and Q. We learned that symbolic language in the last section. And let's see. Then we can make a truth table to say, under what conditions is an and statement true? So we do the cases, 1, 2, 3, 4. Like I said, those are just kind of standardly stamped onto your page to start you out, P and Q. And we said they're either both true, true and false, false and a true, or false, false. That's just standard stamping for a truth table with two possibilities. And then we'll address the question, when is P and Q going to be true? If I said the word and, that means they both are supposed to be true, right? Whenever you're talking, if you say, my name is Cindy and I teach at ACTC, the only time I would assign a truth value of true to that is if both of those were true at the same time, or I'd be lying. I would be lying. So the only time you assign a T for a P and Q, a conjunction, is if you have a T and a T. If both of those were judged to be true, I would say T. Any other time, it's false, right? If one of those is not so, I put an F. And again, this you can just memorize this or have this in your notes, that whenever you see an and statement, two T's makes a T, anything else is going to be F. All right, so the next rule, disjunction. What if it would have been an or? So doing the same thing over again with an or statement, which we learned in the last section, means a V or a disjunction. The word or again is V. So P and Q. We have our four cases where there's just two parts here. So case 1, 2, 3, 4. They could both be true, true and false, false, true, or both false are the possibilities. So when would a P or Q, if I was saying, my name is Cindy, or I teach at ACTC, which would be a weird thing to say, I know, but there's better examples maybe of that. But to say the word or means either one of those could be true, or maybe they're both true. So it's more lenient, you know, more open. So the word or, a true and a true is always true on all of our rules. We'll see that. But a true and a false even is true, because only one half has to be true to be not lying. F and a T is true. So the only time the or statement gets a false is if both parts were false. If I'm not Cindy and I don't teach at ACTC, then I'm just totally telling a lie. But again, the word or is a little more open. As long as one of these is true, we put a T. So again, you'll have this in your notes whenever we get into a bigger truth table, and know whenever we're doing the or that it's more open, and these are the rules you use. All right. The next rule, number 3, a conditional. All right, so we have conditional looks like P, 1 arrow, Q, if, then. So if my name is Cindy, let me erase it in. If my name is Cindy, then I teach at ACTC would be the way you'd say that, which again might be weird, but just making our point here, how we do use the rules. So again, if there's just a P and a Q, we have our standard T, 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 F, F, T, or F, F are the possibilities. And then we're going to judge the rule for if P then Q is T and T is always true. We said it'll be that way for any of our rules. But I call this the broken promise rule. The only time it's not true is if you did whatever the if part was and then it didn't follow through. So a good example, and you can read about this in your textbook, and I hope you are reading your textbook. As far as textbooks go, I'll just say our textbook reads fairly well. It has a lot of good examples and pictures and stuff to kind of go along and make it more interesting. So I think you wouldn't mind reading this math book as much as most would be. But they have a good demonstration in this section that I would draw your attention to. And they have this fella that's standing by a nice car, and the thing was, his father had said, if you get an A, I will buy you a car. This was the deal. If you get an A, I will buy you a car. If, get an A, I'll abbreviate it. Then, so it's an if-then kind of deal, you know, these are kind of deals you make. If you get an A, then you get a car. So, let's say this part was true. You got the A, you got the car. Both of those are true, and a true is true. And that just makes sense in all of our rules. A true and a true is true. But let's say you got the A, and then the part about you getting the car was false, then that's kind of the broken promise. You didn't keep your promise. You said if you get the A, you get the car. So a true, you got the A, and then a false, you didn't give them the car, you kind of broke your promise there, didn't follow up on that. That's the false one in this rule. Now, let's say you didn't get the A, but this in this situation, it was a dad, I believe, in the story. Dad was going to buy a car. So the student didn't get the A. That wound up being a false statement. But you go ahead and give them a car, you know, that's being a little lenient and forgiving or whatever. But you didn't lie. You did not lie about it. It's not a false kind of situation. It's okay to say that's true. You're not lying. It's not a false kind of scenario. And then lastly, let's say this is false. You didn't get the A. And this is false. You didn't get the car. If these both were judged as false and a false, then that's okay too in the conditional. So these are our rules for conditional. Anytime you're doing a truth table and you see the one arrow, if you have a P, then Q, it's true except a T to an F. When you have a T and an F, you put F. And again, we're going to put all this together in a minute, and you'll use all these rules at once. So that's our conditional. Okay, next page. Oh, I guess that was on your next page. You see that rule at the top of page 3. All right, so our last rule, and then we'll get to putting these together. Our last rule is the biconditional. You know, we have these 4 different types of symbols we use, connectives. A biconditional is a double arrow. It's when you see the words if and only if. All right, so here we have a situation. I call this the strict parent. It's very much like the one we just did, except they don't do that kind of wimping out thing whenever they go ahead and give them the car and say they got a C. So this parent's strict, and I'm going to do this if and only if, so it's a two-way street. You got to get the A, and then you get the car. If you don't get the A, you don't get the car kind of deal. So it's the stricter parent. But here's the rule. We've got our P and our Q. Again, if there's only 2 things, there's 4 possibilities for two statements. They're either both true, true and false, false and true, or they're both false. All right, so if we're doing the biconditional, the double arrow, they have to have the same truth value. So true and true is still true, like they have been on every table. A true leading to a false, that's the one that's not keeping the promise. That one's out of the question. And a true leading to a false is going to be false. But also, you can't have this going on if you're a strict parent. You can't not get your A. I guess that's a double negative. Shouldn't say that like that. False would mean you didn't get your A, right? That if we're using the scenario of the car situation. Student gets an A, student gets the car. Well, say you don't get your A and you get your car. That's not a strict parent. We would say that one would not be following through. So it should be a two-way street. They have to have the same truth value. This can't happen. Now the false and the false, that's how it was set. If you get an A, you get a car. If you get the car, you must have got the A. They work back and forth. They're the same deal. If you didn't get the A, you didn't get the car. Didn't get the car, you didn't get the A. So a false and a false, that's keeping the deal the way that you would think it would be understood. When you use the if and only if statement, means they have to have the same truth value. Regardless, those are the rules. I'll try to give you a little narrative to make maybe sense of those rules, so as you're going through, it'll help you, maybe see it a little quicker. You might memorize the rules without having to look them up, but you can always look it up. Lastly, just note, negations have a little squiggle line. If we write, say we have our P and our Q in our 4 situations, that in real quick. And then it says do a not of P or a not of Q. If there's a not, you just look over here to whatever was in the P column and make it the opposite. So a T would change to an F, and then an F changes to a T. So you just write the opposite truth value anytime you see the negation symbol.